Hi, so welcome to best practice in running Scylla on the cloud. Lesson learned from our Scylla Cloud service. So just to emphasize, the idea behind this presentation is how we do stuff on the cloud in case you're running your own cluster on the cloud. What the best practice, in our opinion, you should also do. Of course, if you're a Scylla Cloud customer, you don't have to worry about it. We do everything for you. However, we do still want you to have the best experience from Scylla. So if you decided to run your own cluster, this is what we suggest to do. Okay, I'm Noam Hassan. I'm the cloud team leader. A little bit about our Scylla Cloud. So like Guy said, it's a fully managed service. In my opinion, one of the best things in our Scylla Cloud is that it's a fully Scylla Enterprise version. So by being a Scylla Cloud customer, you're getting everything you get with the Scylla Enterprise, and that includes also the Scylla Enterprise. So the same guys who support Comcast and General Electric, it's the same support team that's going to support you. Even if you create a cluster for 2 weeks and you just want to test it, you're going to get the same support. So that's a great feature. It's self-service. It takes a few minutes. You just register, put in a credit card, and in 5 minutes you have a cluster. Of course, it's multi-region, highly available. Recently launched the DynamoDB, which is the alternative project, which gives you ABI, DynamoDB compatible API. If you want to test it and experience it, instead of compiling the latest Scylla open source code, you can just sign up for Scylla Cloud and test it. Of course, it's in beta, not for production. And one of the latest features we announced in Scylla Cloud is the run on your AWS account. What it means is you get the whole service, the web UI, the self-service, the full management, only we create the cluster on your AWS account. It has several advantages. So for example, some companies have privacy and security requirements in which they need to have all their servers and data located in their AWS account. So this is a great way to achieve that. Another thing is, if your company receives special discounts from AWS, you'll be entitled to them, since we will be creating the servers on your on your account. Okay, so the agenda, I don't have a fancy story for you. It's just a lot of short practical tips we learn and best practice. I don't have a lot of time, so I'm gonna really run fast on those tips. Some of them were already covered in previous sessions by Glober and Tzach, so I'm going to do a very general overview. It does require Scylla knowledge. Usually I like when people ask questions, however, since the lack of time, I won't have time for questions, so please feel free to catch me later and ask me anything you want. I'll be happy to help. You can use this presentation as a reference. Next time you're installing a Scylla cluster, managing, there are some nice tips I think you should use. Hopefully you'll have a little bit better understanding of Scylla internals as we go over stuff and why we decided to do it one way or another. And of course, our hidden agenda is make you a Scylla Cloud customer and save you the trouble of doing it by yourself. So deployment, this is like a very general overview of the deployment, but we use a VPC. We use a single tenant. That's mean for each cluster and each customer we create separate servers, we create a separate VPC, we install its own Scylla Manager, its own Scylla monitoring, and a separate S3 backup. Now, it's very important to know that all the processes, all the stack we use is the same stack that is available for you. We use the same Scylla Enterprise version, we use the same Scylla monitoring stack that is open source and free, we use the same manager. So it's available for you. We don't have any special version just for us. Okay, so separation. We separate a VPC per cluster per data center. That means if you have a cluster with several data centers, for example, one in North Virginia and one in Ohio, you create a separate VPC for each of them. Also, if you're having several data centers in the same region, you'll create a separate VPC. We usually recommend customers to work with VPC peering. Basically, VPC peering in AWS is a way for if you have, let's say, one VPC for your application and one VPC for your Scylla cluster, when doing VPC pairing, you basically connect them together so they can communicate on their internal IPs, which is much more secured. Of course, this is much more organized, especially in your company. If you have one team managing the Scylla cluster, one team managing your application, by creating a separate VPC, each team can manage their own IPs, their own security groups, and it will reduce the risk of human errors. So it is highly recommended. Another thing is create a separate S3 bucket, again, per cluster, per data centers. Make sure to locate the S3 bucket on the same region you created the data center. So if you have, again, a cluster, one data center in North Virginia and one in Tokyo, make sure to create a local S3 bucket for each of them, so the backup will be much more efficient, and of course you won't have to pay for all the network cost. Another thing we do is we use EC2 role for S3 access. So by default, if you install the server and you put, let's say, use an AWS CLI to access to, so that server will have access to AWS APIs, I will run a configuration and store AWS keys on that machine. However, there are several risks with that. First of all, if someone has access to the EBS of the machine, that means the keys are stored locally on the EBS. So if someone, for some reason, a hacker had access to the EBS of the machine, even though he didn't have the SSH key to log in, he can just copy the EBS and acquires those access keys. So the way to solve it is use something called EC2 role. EC2 role is something in AWS in which you define a credential for an instance. And the way it does it, that instance connects to AWS metadata and acquire access keys to have privileges to do action in AWS. Another advantage is if for some reason a hacker was able to access your server, the generated keys are temporary. That means that you will at least have access just for a few hours and you won't be able to use those access keys. So this is highly recommended when you're working with servers on AWS and you want them to do actions on AWS API. Okay, so cross availability zone. There's the whole Scylla REC awareness. Glover talked about it. Is basically Scylla understanding where your server are physically located. And in AWS, you have regions. And in each region, there are usually several availability zones. According to AWS, an availability zone is a physical building that has its own power infrastructure and its own internet connection. So the idea is that if one availability zone goes down, the other availability zone in those regions continue to work in. So we're working with several availability zones. You can take advantage of Scylla ability to locate your data in a smart way and have a higher availability zone for your cluster. However, it does come with a cost. First of all, you can expect an average increase of 1 millisecond in latency to read and write queries. Second of all, there is a network traffic, which is 1 cent per gigabyte in each direction. So this each direction term in AWS is a bit confusing. Let me explain it to you. So according to AWS, if you have one server on USIS 1A and one server on USIS 1B, and you move in 1 gigabyte, so you actually pay for the outgoing information and the incoming information. So when you transfer 1 gigabyte of information, you actually pay 2 cents. So just this is something worth knowing, even for other applications. Another thing, this is a bit more rare. However, again, it's one of those things that when it happens in production, you should be aware of that. It's a bit harder to acquire specific instance types in region in a specific availability zone. So if you're working with the more popular machine like the i3 family in, let's say, North Virginia, you most likely won't have any issue to create a specific machine in USIS 1A. However, in cases where you're trying to acquire i3 EN 8X large in a specific availability zone in Mumbai, there's a chance that you won't get it on the spot. It may take hours, it may take days. And if you already have a cluster in production there and you can create a node, that's an issue. So this is something you also have to take into consideration. Okay, so wreck awareness, we talked about it, and in my opinion, this is the most important tip in my presentation, and like Glober says, always, always, always create a key space with network topology. Basic network topology tells the Scylla, be aware that I have servers in different locations and make sure to distribute the data accordingly. And the reason this is the most important tip is, like Glober said, moving later from simple strategy to network topology strategy is almost impossible. It's a headache. You have risk of data integrity. You have to do a whole migration for your data. So my advice is always work with it, whether it's your local development machine, whether it's just for QA, testing, whatever. Just make sure that be your best practice and your default behavior. Forget about simple strategy. Another thing is snitch. So snitch is a configuration that tells Scylla how to decide where each server is located. So there are different snitches, and it's a property defined in the Scylla config file. One of the snitches that is available is an EC2 snitch. Basically, the EC2 snitch should automatically discover for Scylla where each server is located. However, we don't use that. We use the gossip property file snitch. The advantage in the gossip property file snitch is you control it. You tell Scylla, okay, that server is located in US East 1A, that server is located in Tokyo, in that specific availability zone. It has several advantages. It gives you much more control. For example, a case where you have 2 data centers on the same region because you wanted to have one data center for research and one data center for production. So using this kind of snitch, you can control it. And another thing is for it's cross-cloud compatible. So if you have one data center in Azure and tomorrow you're going to have another data center of the same cluster in AWS, you want to be able to control it. So use this snitch. Okay, network security. So Tzach already covered it. Don't have time. I'll just say that we use security group per kind of role. This is the ports you use. You can look at it later. Same goes for authentication authorization. Tzach went over it. I'll just add that always make sure to create a new user. Create your own user that you understand. Don't use common things like root or admin or SA. Create something that only people in your company will be aware of. You can use this nice utility called pwgen to generate a password. Of course, delete the default Cassandra user, user-triggered user for your application. And of course, there always human need to access production. Make sure they work with read-only access. Okay. Memory setting. So Scylla is a database. That means it loves memory. It wants as much memory as it can get. Unfortunately, it turns out there are other processes in the operating system that also need memory. So how did we try to solve it? First of all, we create a swap. We usually use a 35 gigabyte swap on the EBS. Don't create it on the data volume. It's just easier because it kind of fit all the machines that we use in the i3 family. Swap can be created online. You can create it as a file. You don't have to use a partition. It's just much simpler. You don't have to create partition, resize partitions, and using it as a file gives you basically the same performance, which much easier management. Another thing to take into consideration is reserved memory. So Scylla by default has a configuration for a specific amount of percent out of the total memory of the machine that it reserved for other processes. Unfortunately, in the smaller machine, it doesn't always reserve enough memory. There is a link there how to set the reserved memory for Scylla. This is the amount we use for each instance. So it's a good thing to do. Okay, management. This is a topic that is usually is less touched and overview, but we found it to be extremely important, especially in database. So usually when we have an incident, so we do any maintenance on a cluster, we just want to be done with it and move on to the next thing, and we don't care about documenting it. However, a lot of times, this documentation is very important, especially in a database. A small configuration can have very significant long-term behavior. Things take time until they change in the database, and you want to understand which change how it affected your performance. So in our cloud, we have an application that basically manages the cloud and does it for us, but I think an online spreadsheet can do the job just as well. Just make sure to have it as part of your procedure. So what kind of things we track? Configuration changes, major incidents, what caused them, how we fix them, upgrades, cluster resize. There's a nice utility called etc keeper. Pretty much convert your etc folder to a Git repo. So each time you do change in your etc folder, you can do commits, you can have comments, you can revert back, you can see exactly when someone changed a specific configuration in your etc, for what reason, on what date. So it's a great utility. Another thing is the monitor. Like I said, we're working with the Scylla Monitor open source stack. Use a separate EBS for the data volume. That's the first thing we want to do. In case the data volume reaches 100%, so if it's a separate data volume and not your root for the operating system, the server of the monitor will at least be still accessible. The second is in increasing the default metric retention. I think Prometheus is 30 days. So if you use this row with our stack, you define the location of the separate volume you want to use and how much days you want to retain the data for. Okay, proactive monitoring. So if you use our default stack, you'll have a lot of generic alerts, things like if a server goes down or if you don't have enough disk space. However, in our case in the cloud, we want to make smarter proactive monitoring. We want to understand in advance if a customer is having issue with his application and fix it before he complains about it. So what we do is something called proactive monitoring. It basically means observing your cluster usual or average behavior and start setting up alerts based on it. So always with alerts, you have to be very careful. You don't want to create too many alerts because then you'll start just filtering them. Start to create a few alerts with very low priority and just keep tuning it every several weeks. So for example, you can take the average read latency of the last couple of weeks, create an alert for if you have latency for twice as much, and then start going over that. So this is how we configure it. This is how we configure it. Again, so you can reference later. Another thing to remember, make sure to do the alerts per data center, okay? Each data center, your cluster has different behavior. For example, one latency, which might be healthy in one data center, might be an issue in another data center. So always approach, or generally when you maintain your cluster, try to approach each data center as kind of a separate entity with its own behavior. Okay, this is very basic. Using PagerDuty, PagerDuty is a service that allows you to receive phone calls whenever there's an urgent incident. You can read more about it later. Again, I'll go over it really fast. We work with third-party services, Logs.io, to collect all our logs from all our servers. It's a great service instead of building your own ELK stack. Also, you want to monitor the server of the monitor itself. That means that if you download our monitor stack and install it on the server, it will give you a great solution to monitor the cluster. However, you do need to monitor the monitor itself. If that server goes down, you have no monitor to the cluster. There are a lot of third-party services that can do that and give you basic monitoring for that monitor server. Okay, rolling restart. So the basic way you would, so first of all, rolling restart is when you want to restart your whole cluster one server at a time, and you usually want to do it very slowly and very careful to make sure your application still continues to be online and there's no errors. So the way you do it usually is you just run this command. How actually this command is not the most graceful way of doing it. What you want to do first is run something called drain. What drain does is basically continues to serve applications that are still connecting to the database, allowing enough time to run those queries. And then when it's done, it will stop accepting new SQL queries. Another thing we want to do is sleep between each server. So whenever you're doing a restart to a server, you want to give enough time for all the application to realize that it's back online, to reconnect to it, and you want to give time for a cache to heat up. The whole cache thing is very depends on your application. Maybe for some cluster, 5 minutes is enough. Maybe for some other is 10 minutes is enough. Of course, the longer is the better, but you don't want to do restart to a cluster for over 10 hours. So play with it. This is basically the row. If you have any script that kinds of loops over the servers and run an SSH, this is the command you want to run. So you do the drain. You wait another 60 seconds just to be safe. You restart Scylla, and then you sleep for another 5 minutes before you jump to the next server. Okay, backup, best practice. So when you read a file in Linux, basically Linux uses memory to put that file content on the buffer. That means that there is less memory for Scylla to work. So there is a way that's called direct I/O. With direct I/O, you're basically telling the operating system when you read a file, don't put it through cache. I only want to read it once. I don't care about reading it later. And this is an example of how we do backup. We use DD. We give it a flag of direct, and then we just pipe it to the AWS. So it doesn't happen always, but if you are building a solution, make sure to base it with direct I/O. Okay, really quick, we use Scylla Manager for the repair. Scylla Manager is a nice feature, which is SQL ping, which makes sure it keeps checking your SQL is available on all the servers. And then if the SQL is not available, it will give you an alert. Okay, this is like very generic stuff. Use EC termination protection on all your server. Use Elastic IP on the monitor manager in case you stop them or resize them so the IP doesn't change. Another great tip, set all your server time zone to UTC. It doesn't matter where they sit. It will save you a lot of headache. Tag all your AWS resources, not with just names. So we tag them by project name, department, class ID, account ID. It's very easy to later generate billing reports and understand exactly how much a project costs. Okay, multiple AWS, it's a great thing. Unfortunately, I don't have time to go into it too deep, but there's a way in AWS to define multiple sub-accounts, and that way you can separate between your lab, staging, and production. Basically, what we do in our lab, we give our developer full admin control on that account, so it's a safe environment. They can do whatever they want. We don't have to manage credentials per user and groups. And of course, for production, we have a whole separated account that is much more restricted and only a few people have access to it. Reserve instances, as most of you know about it. Ensure you increase your AWS limits. Moving next. Okay, all use MFA. Whenever we can, we use MFA. You can also force all the user in your company to use MFA. Scylla Cloud also support MFA, so if you have an account, please use it. There is a way to force MFA on SSH. It's called Google Authenticator. It's a great little utility. So basically, if someone does steal your private SSH key, you will still need to enter a time-based passcode, which increases security. And last thing is accumulate your experience. So this is something we learn, automate everything. If you learn something, A lot of time you just, again, want to solve it. You don't use it in the future, you forget about it. So make sure to take your knowledge, put it in automation, and save yourself the trouble in the future.